Good evening, everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. I believe you are all well. Right, tonight, guys, I want to take you through trigonometry in 3 dimension and two dimension, particularly for grade 12. However, I will stick more into trigonometry in 3 dimension, right? Without wasting time, guys, let me take you through the session, and here it's my YouTube channel at Kangaroo Maths and Science Academy. Don't forget to like, subscribe, and hit the bell button for future video notification. Right, without wasting time, now I want to take you through the trigonometry in 3 dimension. Usually we call it the height and distance problems. Right, this is all actually it's part 3 of the session for trigonometry. I've already done a video for trigonometry part 1 and the trigonometry part 2. Part 2 is the trigonometric functions. Right, you know that in most of the cases, trigonometry comes in 3 questions, and it's one of the topic that has a lot of marks. So you need to make sure that you understand all the session of trigonometry. Right, we have what you call a pre-knowledge. These are just the concept that one must know in order to understand trigonometry in 3 dimension and 2D. Right, number one, you need to familiarize yourself with trigonometric ratios, and this has to do with what you call soccer tour. And remember, the trigonometric ratios, you apply them in a right angle triangle. So if we do not have a right angled triangle, then you cannot apply soccer tour, because in a soccer tour, we know that when we have a right angled triangle, if we know this angle, let's call this theta. So we know that in a right angled triangle, there's one side that is always the longest, we know is the hypotenuse. So if you considering theta, it means this side will be the opposite and this side will be the adjacent. By using soccer tour, we know that sine is opposite over hypotenuse, and cos is adjacent over hypotenuse, and tan is opposite over adjacent. Remember, the issue of opposite and adjacent depends on the angle. So if we change the angle now, we use angle, this one. Let's use this one. Let's call this alpha. So you see that this angle, the opposite will be the adjacent of theta. So the opposite and the adjacent depends on the angle, but the hypotenuse is always the same. Right, then now, you remember we use soccer tour only when we have a right angle triangle, which means that if we do not have a right angle triangle, then we must focus, or we must use what you call the sine rule and area rule. So we use sine rule or area rule if our triangle is not a right angle triangle. Then we also have the last one, which is called the area rule. I think this one I've used it in analytical geometry video, where we're calculating the area of triangle to say, in terms of area rule, if we are calculating the area of a triangle, we need to have the side angle that is included and the side. So side, angle, and a side, which means in a right angle triangle, if we have a right, now I'm saying if we have a triangle, let's call this A, B, and C, and we want to calculate the area of triangle ABC. So we can calculate the area of triangle ABC in 3 ways. If we know this angle here, if we know the angle A, then now we can use and say, okay, since angle B is the angle, so this is the opposite side. So we can regard this as small letter B, small letter C, and small letter A, which means these are just the opposite side of those angles, which we have denoted, we denoted them by using small letters. So if we want to calculate the area of triangle ABC, we have to know the side and that angle, and the angle and the side. So to do that means if we want to use angle A, we have to know side C and side B. These are the side that has formed the angle. So it means you're going to say half, then open brackets and close, open and close, then sine of the angle. Which angle are we using here? Angle A. So since we're using angle A, it means here we have to put the size that has formed that angle. So what are the size that has formed the angle? It will be small letter B and small letter C. But if we were using angle B, this will be half, open, close, sine angle B. Let's say we're using angle B here. So if we're using angle B, it means you have to know the size that it had formed that angle. So it's small letter A and small letter C. Then same applies if you're using angle C, it means you have to use small letter A and small letter B, sine angle C. It depends with what you're actually given. But this is the formula for calculating the area of a triangle. Remember, we can also use half base times height. But now in terms of this, we usually use area rule when they say calculate the area. We do not just use it there and there. We use it only when we are told to calculate the area if we do not have a right angle triangle. Then another thing is the issue of sine rule and cosine rule, and this is one of the easiest. Let me try to explain them. In most of the cases, ladies and gentlemen, we use sine rule or cosine rule when SOHCAHTOA fails. If SOHCAHTOA start to fail in a triangle, then we have to opt to use sine rule or cosine rule, because remember, SOHCAHTOA only it's applicable when you have a right angle triangle. But immediately, if you do not have a right angle triangle, then you cannot you cannot use a SOHCAHTOA. So let's consider this a triangle. Let's call this triangle ABC. Just triangle ABC with small, in terms of the side, we have side AC, side AB, and side BC. So side AC is opposite to angle B. So this will be small letter B, small letter C, and small letter A. So according to sine rule says, when you are using sine rule, you need to always consider this. You must consider the side and its opposite angle. Or you consider the angle and its opposite side. So for example, if I want to use sine rule, maybe using angle A, this will be the sine of angle A. Then we divide by the side that is opposite to angle A. It's small letter A equals to the sine of angle B, divided by small letter B, equals to the sine of angle C, divided by small letter C. Remember, the small letters are the sides, the bigger letters are the angle. You can also start from this side and say A over sine angle A equals to B over sine angle B equals to small letter C over sine angle C. Remember, the bigger letters are the angles, the small letters are the sides. We use this called sine rule. This is sine rule. So same applies with cosine rule. If you're using cosine rule, you must also consider the issue of sides and its opposite angle. And how do we use cosine rule? It's straightforward. Cosine rule actually, it comes in three equations from the formula sheet. It only depends on what you are looking for. For example, here it says if you want to use cosine rule, you look at the sides. Let's say we start with side A. So it means you have to square side A. This will be A squared equals to. Then we're going to say, okay, fine. Since you already used the A, what are the other side except A? Obviously, it will be bigger. Small letter B plus small letter C minus 2 times the letters that we have used, like the letter B and C. So this will be the B multiplied by the C, the cos of the angle. The angle that we're going to put A should be opposite to this side. So it's small letter A. So which means if you want to get want to know about side B, then it means we have to take that side, we square it. And what are the other side that do not square except B? It will be the A. So you have to take A squared plus C squared minus 2 times those A's and B and C's. Then the cos of which angle? Angle B. So it means if I want to consider the last side, which is side squared, C squared, I mean to say, it's the side. So I've squared the C. What are the remaining sides except C? Obviously, it will be small letter A and small letter B minus 2 times the A and the B cos of angle C. So consider all the time, this angle should be opposite to this side. The side and opposite angle, very important. The side and the opposite angle. So this is cosine rule, cosine rule. So in most of the papers, usually, when we have a right angle triangle, ladies and gentlemen, you can use SOHCAHTOA. But if you do not have a right angle triangle, it means SOHCAHTOA fails. It means you must try sine rule or cosine rule. But we'll talk about this. We use area rule only when we are told to do so, particularly when they say calculate the area of a triangle. Then the last thing that you need to know is to understand the issue of triangle. For example, knowing that sum of angles in a triangle add up to 180 is very, very important in height and distance problem. And again, the issue of isosceles triangle is also important. Isosceles triangle, that if two sides are equal in a triangle but not equal to the third one, that is an isosceles triangle. And we know in an isosceles triangle, if two sides are equal, even the opposite angles also they're equal. So it's equal sides, equal opposite angles. So it's very important to know this property. And another property is the issue of parallel lines. Sometimes they can tell you that a certain line is parallel to another in order for you to relate the angles. So it's very important to be able to understand what you're actually given. So without wasting time, let's deep dive into the examples. However, ladies and gentlemen, I will not go through all the questions because I think in this paper, there are around 7 questions. So what I'll do is I'll just try to go fast on some of the questions. However, if I did not finish some of the questions, kindly go through them on your own and try to prove and check if you are following or not. Right. For example, if we were to go through this is question 1. After question 1, we have question 2. Okay, this is a 2D shape. Question 2, we have question 3. Question 3, it's question 4. It's still height and distance problem. Question 5, question 6, and question 7. So this is the last one. So what I'll do is, okay, I'll just try to go through. If I don't finish them, then you will have to finish on your own. Right, without wasting time, let's look on the first one. Let me try to zoom so that you can see the questions nicely so, okay? Sorry. The first one, it says, in the accompanying diagram, ABD, in the accompanying diagram ABD, what is ABD? Okay, we're given a diagram ABD. Let me try to draw it. This is A, B, and D. ABD is a horizontal plane. They're just horizontally. And BC from B to C is just a pole which is perpendicular to this horizontal plane. And now we are told that AD equals to BD. AD and BD are equal. AD and BD are equal. So we are told that that's from A to B and from B to D, the sides are equal. The angle of elevation from A to the top of the pole, which is C, it's X. So we're given this angle here, it's X. And A angle DB from A to D, from D to B, this angle here is 2X. And the question says, prove that AD, we want to prove that AD is equals to H cos of X over 2 sine squared X. So this is what you want to prove. Ladies and gentlemen, you need to listen to me. Like, this is one of the easiest questions in height and distance. Like, let me say in trigonometry. Number 1, before you start solving your proving, try to isolate your triangle. Isolation is the best. First of all, let's check how many triangles are in this diagram. By looking at the diagram, we have 3 triangles. There are 3 triangles which are here. So let's redraw them separate and try to analyze them. The first one, I'm going to draw it here. The first triangle is this one, is triangle A, B, C. Let's first identify the type of this triangle. This triangle is a right angle triangle, and the height is h. And what is the angle there? Angle is x. Right. In most of the cases, when you are analyzing diagram like this, try to solve, like analyze each and every triangle there. Number one, we know that angles in a triangle are adding up to 180 degrees. So it means we can get angle C here. It's very important because sometimes you might find that you need to get that angle. You have to use it. And we know that angle in the triangle add up to 180. So let me say for now, if I don't know this angle plus the x plus the 90, this is 180. We know angle in the triangle add up to 180. The angle that we don't know here, I can remain with it. It's just going to be 180 minus 90 minus x. 180 minus 90 minus x is just 90 minus x. I'm just showing others, but I know already it's 90 minus x. So this angle here, it's 90 minus of an x. Okay, is the first triangle that we got. From B to C, we're told that the height is h. I'm saying it's just h units. And again, we have the second triangle. Here is the second triangle, guys. Okay, let me use the same color. The second triangle is ABD. Let me just draw it here. ABD, this is not the right angle triangle. It's not the right angle triangle. So from A to B, from B to D, we are told that the sides from A to D, the side is the same as from, let me use a different color. From A to D, it's equals to BD. AD is equals to BD, it's what you are told. And yet the angle here is 2x. The angle here is 2x. So what does this mean? It means now we need to first analyze these two diagrams. Otherwise, if we do not analyze them, we wouldn't be able to prove it. Right, now we know that angles that are in a triangle, they must add up to 180 degrees. So let's do this without wasting time. In triangle ABD, we only know that from A to D is equals to from B to D. So it means this is an isosceles triangle. And we know that in an isosceles triangle, if two sides are equal, even the opposite angles are also equal. Equal sides, equal opposite angle. What does it mean? It means this angle A here, this angle here, and this angle are equal. So we need to solve them. How to do that? We can do this. We can say, okay, right? Just to simplify our work, we can just say, okay, right? In triangle ABD, we want to show all the workings, guys. In triangle ABD, I'll just use question marks for now because I don't want to waste time. We know that the two angles must be equal. Okay, let me try to solve. Okay, we do not know this angle and we do not know this angle, but we know these two angles are equal because this is an isosceles. So I will say the angle that I don't know plus the angle that I don't know, which are actually equal. I'm just using question marks for now, but it's not what you should do. Plus 2x equals to 180 degrees because the angle, the sum of angles in the triangle. So okay, or for now, with let me just use. Yeah, I believe you're following. I'm just using question marks for this so that you can understand. So because the sides are equal, these two sides are actually equal. This is an isosceles, so it means the angle here and angle here are equal. So now we are having how many angle? Two angle, which we don't know. Is 2 question mark equals to 180 minus 2x. Let's divide everything by 2 to get each angle there. Dividing by 2, 180 divided by 2, it's 90. 2x divided by 2 is just x. So it means each angle here is 90 minus x. It's 90 minus x. It's very important, guys, to understand what I'm actually doing here. So we know these two angles now. Each angle is actually 90 minus x. 90 minus x. So this is 90 minus x. It's 90 minus x. I believe you understand why I'm saying it's 90 minus x. Remember, they're equal, so it means they have to share from 180 minus 2x. So if you take 180 minus 2x, you divide everything by 2. So it will be 90 minus x. 90 minus x. Okay, fine. Then now since we have two triangles, let's check something before proceeding. Let's now identify the type of triangles we are dealing with. The first one, number one, let me just call this number one. Let me call this one, and let me call this two. In the first triangle, we have a right angle triangle because this is an angle of 90 degrees. So it means in the first triangle, we can use SOHCAHTOA. So it means SOHCAHTOA, it's applicable in the first triangle. Second triangle, we do not have a SOHCAHTOA, which means it will fail here. So we have to either try sine rule or cosine rule where possible. But usually, if we use sine rule, it fails, then it means we have to use cosine. Usually, I encourage my learners to do that, to say, if you try sine rule, if sine rule fails, then you move to cosine rule. I believe you guys are following. Now, let us check what we are looking for. Then now, before we start, okay, yeah, just I apologize, guys. I want to emphasize something very important. In most of the triangles, you need to check for a side that is common. You know, a side that is common in the two triangle, it's one of the most important ones because we'll use it to move from one triangle to another. Let's look at these two triangles. Do we have a side that is common in two triangles? Let's check. AC it's not in the second triangle. BC it's not, it's only AB. So it means this AB, it's one of the most important side in these two triangles because it will help us to move from one triangle to another. So it means whatever we're going to resolve, we need to resolve using that common side. It's very important. Number one, what do you want to prove? We want to prove that AD is equals to H cos X over 2 sine squared X. First, let us check where is this AD. If you can look at the two triangle, AD, it's in the second triangle. It means you have to use this triangle. But now, look at this. We need to prove that AD is equals to H. Where's this H? H is not in triangle ABD. It is in triangle ABC. And in triangle ABC, there is no AD. So what does this mean? It means that we must go and pick that H so that we can use it in the second triangle to write it in terms of AD. Because in the triangle ABD, there's no H, but here they want us to use H. So what does this mean? It means that we need to go to look for a common side that will enable us to use H in triangle ABD to get the AD. How are we going to do that? We're going to say, okay, fine. Because now we want AD, and this AD inside it, there's H, and H is in the first triangle. So we have to say in triangle ABC. I want you guys to listen to me. In this triangle here, remember we want H to be part of our proof. So what does it mean? It means you're going to certify. And beside we have the X. X is also part of. So in triangle ABC, in this triangle, we have our angle here, it's angle X. And since I said we can use SOHCAHTOA, what is the opposite of this angle? It is the H. It's the opposite. What is the adjacent of this angle? It is the AB. And what is the hypotenuse? It's AC. Now, what did I say? It means now we have to rewrite AB to be in terms of H and X. So first of all, we have to write AB to be in terms of H and X. Why H and X, guys? Because if we write it in terms of H and X, we'll be able to come and use it in the second triangle. So how are we going to do that? Remember, it means now we're going to check. We want this X to be part of our expression, but the H should also be part and the AB should be part of. Why AB? Because AB is a common side. So I'm going to use, let's check. Opposite is the H, adjacent is AB. So it means I'm going to use tan. So I'm going to say the tan of angle, what is our angle? The tan of angle X its opposite over adjacent. What is the opposite, ladies and gentlemen? The opposite is the h over. What is the adjacent? The adjacent is the AB. So it means now we want to write AB to be in terms of h and x. Why? So that we can be able to use it in the second triangle because there's also AB. Common side, guys. It's a fraction, it's over 1. We can cross multiply. So we're going to have AB tan x equals to h. Then let's divide by tan x, both sides. Then now it means the AB is equals to h over tan x. You see what we have done here? We wrote AB to be in terms of h and x. Why? Because in our proving, they need this h, and h is not in triangle ABD. So that's why we have to use a common side to move from one triangle to another. Now we know this, the side of AB in terms of h. Then now we can now determine our AD. And to determine the AD, since ABD is not a right angle triangle, so I'm going to say in triangle ABD, this is not a right angle triangle. So let's try sine rule first. Trying sine rule, first of all, let's do this to make our work to be easy. Let's look at the angle. We have angle D, and what is the side opposite to angle D? It's AB. So instead of just talking about AB, let's just use small letters. I want to use small letters. So let's say AAD, small letter D, sorry. AB is opposite to AD, so it's small letter B and small letter A. So I want to use sine rule because this is not a right angle triangle. If sine rule fails, that means you have to use to cosine. We have to move to cosine. So I'm going to say sine angle A divided by small letter A, sine angle B divided by small letter B. It's sine rule, sine angle D divided by small letter D. Let's check what do we know already. Number one, do we know angle A? Yes, we know angle A is 90 minus X. Do we know small letter A? Small letter A is BD. We don't know, but they're equal with, so we do not know this. Do we know angle B? Angle B, we know it's 90 minus X. Small letter B, we do not know, but it's what we are looking for actually. Let me just say it's what we are looking for because small letter B is our AD. Angle D, what is angle D? Angle D we know is 2x. And small letter d, it's just what we just got now. It's the AB, so we know this. So we are going to look on the expression with one unknown. But since we are looking for small letter b, it means we are going to use the first one, the second one. So we're going to say sine angle B over small letter b equals to sine angle D over small letter d, because we have one unknown and we are looking for small letter B. What is angle B? Angle B, we know it's 90 minus X. What is small letter B? Small letter B is our AD. It's what we are looking for. Sine angle D is our 2X. Small letter D is our AB, and we just got AB just now. So now we can simplify this expression by doing this. Already since we're done with, let me just erase some of the concept here. Okay, right. Without wasting time, let me simplify this. Okay, let me just erase some of the information because already we know. Let's now simplify this. We're going to say, okay, right. From what we got, let's simplify this. Now, when we look on our expression, we have sine 90 minus an angle, sine 90 minus an angle. Okay, just a minute, guys, just a minute. Okay, guys, I apologize. Right. As I was saying that we have an expression that needs to be reduced. Here we have 90 minus an angle. So it means you have to use the reduction formula. 90 minus an angle is in which quadrant, guys? 90 minus an angle as a reduction formula, it is in the first quadrant where sign, like 90 minus an angle is in the first quadrant where sign is positive. But because of 90, it will change and become cos. So this is cos x divided by 8d. It's what you're looking for, equals to sine 2x divided by AB. AB, we have it, we'll substitute, we have the AB, it's here. So let's cross multiply and make, I apologize, guys, I've returned to ABs. So it means you're supposed to have AD. So let's cross multiply. This will be AD sine 2x equals to AB cos of x. Now, without wasting time, we can divide there by sine 2x because we want to get AD sine 2x. Then now, or before we divide by sine 2x, but no, it's fine. There's no problem. Let's just divide it by sine 2x. So what will this give us? Then it will give us, let me just, let me erase here, guys. It will give us AD is equals to AB cos x divided by sine 2x. So it means this will be, the AD will be AB cos x divided by sine 2x. But since this is for grade 12, then now what we're going to do, where there is, okay, this actual, I can even write it like this, guys. Divide by sine 2x. Okay, but it's fine. Let's just not do it like this. But still, I can even make a fraction. There's no problem. Okay, let's do this, guys. Sorry. Let's just substitute the AB by our expression that we got. AB is equals to H over tan X. I'll just put it inside brackets, multiply by cos X, divide by, look at the, this one is it's a double angle for cos. So this is the same as 2 sine X cos X. So now it means the cos X and the cos X will divide. So we're going to remain with AD equals to H over tan X at the numerator, divide by 2 sine X at the denominator. Okay, I believe you guys are following. Then without wasting time, I want to change this over 1. Let's now change division into multiplication, but still, okay, fine. Let's just do this for simplicity. I wanted to change where there is sign to be, and where there is, okay, it's fine. Let's just say AD equals to H over tan X. I want to change division to multiplication. This will be 1 multiplied by 1 over 2 sine X. I believe you guys are following, right? Let me, okay, it's fine. We can erase this part here. Now, let's now multiply the numerators and denominators together. What do you have? This will result to the following. We'll have the AD, because we change division to multiplication. You know how to do that? So now we can multiply the numerator. This will be H times 1 is H over. What is tan X multiplied by 2 sine X? This will actually give us 2 sine X tan X. If I'm just multiplying. So I'm going to now do this. This is H over 2 sine X. What is tan? Tan, we know it's sine over cos. And this over 1 because we're having a fraction. So it means that this will result to I apologize. H divided by, let's multiply the numerator. This side, this will be 2 sine squared H divided by 1 multiplied by cos, it's cos x. You still see that you still have another fraction. This will be H divided by 2 sine squared x over cos x. We can change division to multiplication by making this over 1. So it means our expression would be, the AD would be H over 1 multiplied by, then we make the reciprocal, which is cos x divided by 2 sine squared x. I believe you are now following. Let's now multiply the numerator and denominator. What is H multiplied by cos x? It's just giving us H cos x. And then what is 1 multiplied by 2 sine squared is giving us 2 sine squared x. So we've proved. Remember, I'm following all the steps to allow everyone to understand what I'm actually doing. But in most of the case, guys, you need to separate the triangles. You first identify whether you're going to use SOHCAHTOA or not, then you take it from there. Right. I believe you are following. Let's now move on to the next question. Oh, okay. I apologize. Let's move on to the next question. Right. Okay. Let's check. Okay. This is 2D. No, it's okay. Let's just go straight to question to question. It will be easier that way. Okay. Right. Question 2. This has a bit of Euclidean geometry. So in this question, they're saying in the figure, let me try to zoom this. Right, I believe you can see. In the figure, PQ is a diameter. PQ is a diameter. They told us that PQ is a diameter. From P to Q, this is a diameter. So it means this one we have to use that theorem of the diameter, which says angle that are subtended by a diameter. Angle subtended by a diameter at the circumference by a diameter at the circumference is equals to 90 degrees. Is equals to 90 degrees at the circumference. You see, the chapters are linking. So you need to make sure that you understand this. So let's go and trace the angle that is coming from this diameter, PQ. Its angle is this S. It means this angle here should be equals to 90 degrees. So you can say, because they do not mention whether it's S1 or S2, so you can say P angle SQ, it's 90 degrees. That is the reason. Angle in a semicircle. Right. PQS is a straight line. PQS is a straight line. PQS is a straight line. And QR equals to QS, which equals to X. They told us that from Q to okay, I apologize. From Q to R, where is R? From Q to R, this side is equals to QS from Q to S. Okay? It means something here. See that we have an isosceles triangle. So now, first of all, what did I say? Okay, they said it's X, and they said that it's X. First of all, we need, okay, P angle P is Q is theta. This angle is theta. Let's first isolate the triangle. The first triangle is this one. The one we just got now, is this one. Let me just say it's Q, it's S, and it's P. And that is an angle of 90 degrees. So now we have a right angle triangle. This angle here, we're told that is theta. And what does this mean? It means the angle, we know can get the other angle. Angles in the triangle must add up to 180 degrees. So this is theta. This is 90. So this angle here is the one which is 90 minus theta. So this is 90 minus theta. So it's a right angle triangle, so we can use SOHCAHTOA. Okay, another triangle. Another triangle is this one. Okay, that's R. There's Q, there's S. This side and this side are equal. And we know if these two sides are actually equal, this triangle is our isosceles triangle. So it means this angle and this angle are equal. And what is the last triangle? The last triangle, I think, is the bigger one, but I don't think we'll be using this. Okay, I should have different. I should have used different. Okay, it's R S P. P is the one which we know is theta. The rest we not know. Okay, fine. I think that one we can leave it for now. So now, before we start doing this, is this a right angle triangle? No, it means we cannot use soccer tour. It means here there's a possibility of using sine rule or cosine rule. But usually if sine rule fails, then we have to move to cosine rule. Besides that, let's try to analyze something. In this triangle, since here it's theta and it's 90 minus theta, and it's also the same as this one. This is 90 minus, we got this is 90 minus theta. So which means if we know this angle here, it's 90 minus theta, we can be able to get the other angle here. Why? Because this angle are on a straight line, they have to add up to 180. So which means the angle that I don't know, if I can say the angle that I know plus the 90 minus theta, this should be 180. Or we can also use the exterior angle of a triangle, it's also fine. So we can say the angle that I don't know, this would be 180 minus 90 plus theta. So 180 minus 90 is 90 plus theta, which means this angle here, this one, it's 90 plus theta in the other triangle. This is 90 minus theta, and this is 90 plus theta because they're on a straight line. Or you can also take it as an exterior angle and say exterior angle equals to the sum of the opposite interior angle. It's also fine. And what does this mean? If we know this one, it's 90 plus theta in this triangle, but these two angles should be the same, then we can be able to get the other one. So what will be the answer for these two? I think each should be 90 minus theta over 2, if I'm not mistaken. So let's just check that. Let's say we do not know this, because we don't know and they're equal, so I'm going to say both of them, I don't know them. But if I can add with 90 plus theta, this should be 180 because the angle in the triangle. So it's two of them. Let's transpose 180 minus 90 or minus theta. Now I see. So it means the answer was supposed to say, okay, so two of them, this is 90 minus theta. Let's divide by 2. So it means each should be 90 minus theta divided by 2, which is just 45 minus theta over 2. So, but I think we can leave this. We can leave this. So it's 45 minus theta over 2. 45 minus theta over 2. I don't think we will be able to use them. But now, it's fine. But it's very important to first analyze the diagram. Another thing, guys, is to look for a common side. Let's look for a side that is common in the two triangles, because with this triangle, I don't think will be used because it does not have enough information. So we're going to use this triangle and this two. So let's look for a common side. It's very important to look for a common side. Let's check QS, or QS is there even this side. So we have QS, or QS is the common one. And by the way, is the one which is equals to X. They said the QX are equal. So it means even here it's X. So it means that common side is the one that we have to use in order to move from one triangle to another. We have any information except that. Let's look on the first triangle. We have QS is X. SP, there's no SP in the second triangle. RQ, okay, fine. Let's now go through the question. Right, the first question says prove that RS it's equals to X times 2 the root of 1 plus sine X. Obvious, guys, where's this RS? Let's first trace where's RS. RS it is in this triangle, this one. Our RS is here. And in this RS, there's X, there's theta. So which means there's no need to use the first triangle. We just have to use this. And by the way, look at this. Already in this triangle, the second triangle, this is not a right angle triangle. So we have to either use sine rule or cosine rule. But now, because of this root sign here, it's an indication that we have to use cosine rule. There's no need to move to sine rule because that root sign shows that you have to use cosine rule so that when you're going to because cosine rule comes in squares. So it means in this case, we have to use cosine rule. So let's use cosine rule. Using cosine rule, so I'll just do this. Let me draw this triangle here so that we can be able to see it again. Here it's our triangle. So that's R, that's S, is what you're looking for. That's Q. Let's make small letter Q, small letter, because it's the opposite, small letter R, small letter S. What do we have? We know size. They told us that QR and QS are equal, they're both equals to X. And we know the angle between it's 90 plus theta. Okay, let's now use cosine rule. By the way, we use cosine rule. First of all, let's check what we're looking for. We are looking for RS. And what is RS there? RS is the small letter Q. So since it's the small letter Q, by using cosine rule, because I've told you have to use cosine rule here. So I'm just going to say cosine rule by cosine rule because of the square root. What are we going to do? We consider the side that we are looking for. We're looking for small letter Q. So it means we have to first square that small letter Q because it's the RS. So I'm going to say Q squared is the side that I squared. What are the other side except Q? It's R. I'm gonna square R and S multiplied by 2 times R times S, the cos of angle that is opposite to this side Q. It's angle Q. So let's do the substitution. Small letter Q, it's what we are looking for. It's RS squared. Small letter R, what is small letter R? Small letter R is QR. We have this. Small letter S is QS minus 2 times QR times QS, the cos of an angle. What is our angle? The angle is 90 plus theta. We got it. Now we're going to simplify. This is RS squared. QR, we told that QR and QS are equal. So where there is QR, we're going to put X. QS also X. 2 times QRX, QSX. 90 plus an angle, which quadrant? 90 plus an angle is in the second quadrant where cos, it's negative. But because of 90, it's a cofunction, it will become sine theta. So this will give us RS squared. It's X squared plus X squared minus, let's multiply this. This is just a multiplication. Negative times negative, this becomes positive. 2 times X times X times sine X, this becomes 2X squared sine theta. I apologize. Then this will be, also these are like terms. This is equals to 2X squared plus another 2X squared sine theta. What is a common factor? Let's take common factor. The common factor here is 2X squared into, we remain with 1 plus sine theta. Now we want to determine RS, not RS squared. So this becomes 2X squared into 1 plus sine theta. Then we apply root sine. Now, here we're going to use SATs. We know that the square root of A times B, it is the square root of A times the square root of B. So what I will do here, I will just say, okay, fine. Because now, okay, this is RS. This is the same as the square root of X squared times, because the square root of 2 will give us the decimal, I'll just leave it inside. The square root of 2 into 1 plus sine theta. And what is the square root of X squared, guys? it's x. The square root of this will just remain the root of 2 into 1 plus sine theta. So we have proved our expression. We have proved our expression. I believe, guys, you're following. Then what is the second question? The second question says if RS equals to root 12. So we're given RS, let me just write the information here. It's root 12. We're given X is 2. Then the question says, show without using a calculator that the theta is 30 degrees and PQ equals to 4. The theta it's 30 degrees and PQ is 4. What is this PQ? Okay. We want to show that theta is 30 degrees and PQ is 4. When X is 2. Okay, fine. First, let's do this. Because we are given all the information here, let's just go through what we have proved. RS equals to X, the root of 2 into 1 plus sine theta. 1 theta first. Let's substitute where the RS, we know it's root 12. X is 2 into 2 times 1 plus sine theta. So let's first divide everything by 2. Let's get the dog the 2 here. Root 12 is the same as 2 root 3, if I'm not mistaken. Yes, 2 root 3 or root 12 divided by 2, this will just give us a value of root 3. So this will give us a value of root 3. So this will be root of 3. Then you're going to remain with inside the root sign 2 into 1 plus sine theta. Want to solve for theta, so it means you must get rid of the root sign. How to do that? We square both sides to remove the square. So it's going to be 3 into 2 into 1 plus sine theta. Let's divide everything by 2. So we're going to have 3 over 2 is equals to 1 plus sine theta. Then let's now transpose 1 to the left-hand side. 3 over 2, subtract 1. So it will be 0.5, it will be half sine theta. Want to get the theta, let's make second function. Theta is the second function, sine half, which will just give us 30 degrees. So we have shown this, that theta is 30. But now we also want to show that PQ is equals to 4. Where's the PQ? Let's trace where we have the PQ. Let me erase this information. Remember, I wanted to show that theta is 30 and PQ is 4. Okay. Why this PQ? PQ is in this triangle, okay? I think we have all the information, guys. Let's first identify the triangle where we have PQ. There is 90, it's S, that's Q, there's P, and here we just got this angle theta is 30 now. Oh, okay, fine. What is our QS? Well, QS, remember they said QS and RS are equal. So it's X, and our X we have is 2 there. So it means we can, remember, we can use soccer 2 now. So we can say, since we have the 30 is the opposite, and we want to PQ is the hypotenuse, so we're going to use sine. So sine 30, it's opposite over adjacent. What is the opposite? The opposite is QS. Adjacent is PQ. So over 1, then we can cross multiply. So this will be PQ sine 30. What is QS? QS is 2. It's X. So it's divided by sine 30. and divided by sine theta. Sine theta already is half, so 2 divided by half will give us 4. So it means PQ is 4 units. I believe you guys are following. Remember, practice makes perfect. PQ is equals to 4. We have done that. All right, let's move on to the next question. Okay, went through number 2, number 3, and number 4. And 6, even 6, and 8. Okay, let's just go back to our question. Okay, question 3. What do we have? In the figure, Q is a foot of a vertical tower. Q is the foot of the vertical tower, PQ, while R and S are 2 points in the horizontal plane, SQ. Okay, the angle of elevation of P measured from R, it's X. So we're given this angle here, it's X. And the R angle QS, it's Y. This angle here, it's Y. Then QS, it's A. They told us that from Q to S is just 8 meters. And the area of triangle, so they've given us the area. The area of triangle RQS is H meter squared. So it means the area is H of RQS. Number 1, before starting with the question, remember I said you need to isolate our diagram. Let's now isolate. So the first triangle will be this one. Okay, let me just draw it to be exactly S. Okay, PQ. Okay, the first one is this one. Okay. Okay. Okay, there's an angle of 90 degrees. There's P, Q, and R. This angle here is X, so which means this one it's 90 minus X. Then the second one, we have this one. It's 90. P, Q, and S. Here is small letter A for the side. Okay, we only know the side in this triangle. Then the last one is this one. But this one is not the right angle triangle. What do we have? We have Q, we have R, we have, I'm going to say, sorry. We have Q, R, S. The only information we have here is just the angle is the Y, and the side which is the A. So let me just use the side as the A, okay? So this is what we have. Okay, fine. First of all, let's look at this. This is a right angle triangle, so we can use Socatrua. This one is also a right angle triangle, but we only have 90 degree. I only have the side in this triangle, so I don't think we'll be using that. So it means the triangle that I believe maybe we might be using is this two. Since it's this two, let's look for a common side. Common side. PQ, it's not in here. QR, it's there. Yes, QR is there. So this is a common side. We need to consider this. So which means if we want to move from one triangle to another, we need to use that QR there. Now, what does the question say? It says, prove that PQ is equal to 2H tan x divided by a sine y. Let's check. PQ, where is PQ? In which triangle? In this triangle. PQ is there. Let's check. In this triangle where we have PQ, does this have the H? No, the H is not there. What is this H? The H is the area. So it means in our calculation, we have to have the H, like we must use the area, must use the property for an area. Okay? Right. Another thing, it's X. Does this triangle has X? Yes, it does have X, and it uses tan. So it means you have to use tan. And Y, where is the Y? The Y is in this triangle. So it means you have to move from that triangle to this one. Another one, it has small letter A. It's there in this triangle. So what does this mean? It means we have to use a common side. And how to do that? Let's do this. First of all, because we want PQ, we're going to say in triangle PQR. Let's now write side PQ that we're looking for in terms of QR. Why QR? QR is a common side. And what? And X in terms of QR and X. It will be easier that way. So it means we first identify the angle. The angle is X. What is the opposite of X? This is the opposite, is PQ. And what is the adjacent? It's QR. So it means we're going to use opposite over adjacent, which is just tan. That's why we have tan here, okay? So I'm going to say tan of X. Okay, let me use a different color. Tan of X, it's opposite over adjacent because this is a soccer tour. Tan of X, what is opposite? It's a right angle triangle. Opposite is our PQ, it's what we're looking for. Adjacent is our QR, and QR is a common side. That's why I want to have this so that I can move into the second triangle. So let's cross multiply. It means the PQ now is equals to QR multiplied by tan X. That is equation number 1. So it means this QR is the one that will assist me to come in the second triangle. But now look at these guys. Now we have rearranged PQ, like like I've expressed PQ to be in terms of QR and X. Why QR? QR is a common side. So now it means now I have to move to the second triangle. Ladies and gentlemen, moving in the second triangle, it means now I have to use the area. Why? Because they gave us the information for the area of this triangle. And guys, how do we calculate the area? Remember I said you can calculate the area only when you have this condition. You know the angle and the side that has formed that angle. So let's do this because we want to have this to be in terms of H. Area of triangle RQS. It's half open, close, half open, close, sine of the angle. Which angle do you want to use here? I will use angle Q because I know this is angle Q. So what are the sides that are in that formed angle Q? It's QR and QS. So I'm gonna put QR here and QS because these are the side that has formed that angle. And what is the area? The area is H, guys. We know the area. Half into QR. QR we do not know. So I'm gonna write everything to be in terms of QR. QR we do not know. So it's what we are looking for. So we're gonna have the QR because if we do not use this area part, then we're not gonna be able to answer the question. What is QS? QS is small letter A. Sine of which angle? Angle Y. So let's make Q as the subject of the formula. So this will be, let's multiply this. This will be H equals to half A sine Y multiplied by QR. Actually, let me rearrange this. This is the same as A sine Y QR divided by 2. It was the same as half. So it's over 1. Let's cross multiply. So it will be A sine Y QR equals to 2H. Let's divide by A sine Y, both sides. A sine of Y divided by A sine of Y. So it means what I'm going to get here is the QR. I have the QR. So the QR is 2H over a sine y. So it means where there is, in this expression, because we want PQ, where there is QR, I will substitute by that. So it means this will be PQ equals to, what is the QR? I'm using this. QR is 2h over tan x. Then, no, not over tan x, I apologize. Over a sine y. It's over a sine y, a sine y. Then times tan x. And since this is a fraction, then it means this should be over 1. Let's now multiply the numerator. PQ will be 2h tan x divided by the denominator. It's a sine of y. So we now prove the expression. Very important. You need to consider what you are given. Use what you are given. Okay? What is the next question? Okay, let's look at the next question. The next question says, hence determine the value of y. Straightforward. Hence determine the value of y if PQ is 77. Small letter a, it's 89 meter, just the distance. H, which is the area, it's, so we have everything. Actually, we can just copy the equation, say PQ equals to 2h tan x over a sine y. Oh, we want angle y. So to do that, let's do the substitution and get the answer. It's just straightforward this way. What is the PQ? PQ is 77. So let's do the substitution. 77 to, what is the H? 1408. Tan of, what is the X? 46.5 over the side of A, it's 89 sine y. We want this angle. So obvious, this is a fraction, make over 1 cross multiply. 77 times 89. This will give us 6,853 sine of y equals to 2 multiplied by 1480 multiplied by the tan. What is tan of 46.5? So this will give us 3. Okay, let me just write the whole, then I'll just write the final answer here. So I'll just say, okay, 2 multiplied by 480, this will be 2960 tan 46.5. Let's divide it by 6853 and 6853. And this will give us sine of y. So I'm gonna say tan 46.5 divided by 6853. So this will give us 0.46. Then we make second function sine of that. Second function sine of 0.46. So it means the angle will be 27.39 degrees, if I'm not mistaken. 2 by 1480 by tan 46.5 divided by 77 times 89. Yeah, second function sine of an answer, roughly 27. So in other case, 27.08. So 27.39. So that is the answer. Okay, I believe, guys, you're following. Okay, so we went through number 3, then dates number 4, and number 5. You see, this one, it shows that for you to prove it, you must use cosine rule, this one, because of this root sign. The root sign is an indication that you have to use cosine rule. But don't forget, remember, you isolate your triangles. You try to prove on your own. Okay, then now, let me check. Right. I think if I can just go through question 6 and 7, then on your own, you'll try to do question 5 and question 4 on your own. So you just pause, then you do it on your own. You prove that, show that B equals to K cos X over sine Y minus X. Then even 4.2. And after that, you move on to question 5. So for now, I'll just go through question 6 and 7. Then you do the other questions. Wherever you're failing, then you reach out to me, then I'll be glad to assist you. But let's look at the question 6. In the diagram alongside PQ and R are 3 points in the same horizontal plane. PQ and R are 3 points in the same horizontal plane. And SR is a vertical tower of H meter. SR is given there. The angle of elevation of S from Q, it's theta, or this is the theta. And R angle QP from R to Q, Q to P, so they're referring to the whole of this angle, is 30. PQ is 6 meter, from P to Q it's 6 meter. First of all, let's isolate the triangle, guys. When I look at this diagram, I think we have two triangles, which are very important to use here. The first one is the PRQ, and this PRQ is the one which is the right angle triangle. By the way, what is the angle here? The angle here, it's theta in PQRQ. You can see it is from here up until here. So it is in this triangle. I believe you can see it, guys. Right, if it's theta, it means you can get this angle also. This is 90 minus theta. And what is the height here? The height is H. We know the height is H. SR. Sorry, I apologize. I said P in terms of S. Should be SR. And the other triangle is this triangle, this one. What do we have? We have P, Q, and R. What is the whole of Q? All of Q is 30. What is R? Angle R is theta, so we can get this. I think this will be 150 minus theta. Why 150 minus theta? Here's the answer. Let's assume, let me put question mark here. You can say this plus 30 plus theta, this will be 180. So let's transpose the two. 180 minus 30 minus theta, which is 150 minus theta. So we know this angle here is 150 minus theta. Okay, so these are the two triangles which I believe we'll be using. Right, let's now check something. Oh, the length of PQ, they gave us that from P to Q, it's 6. So let's write this 6. It's 6, and there's H. Number one, as a rule, as a norm, let's look for a common angle. I'm saying common side. QR is in this triangle, and QR is also in that triangle. So this is one of the most important side to consider, because it will assist us to move from one triangle to another. And the other one, let's check PQSR. Okay, fine. We don't have any common ones. But this one is a right angle triangle. The first one means you have to use SOHCAHTOA. The second one we'll have to use a sine rule or cosine rule, because we do not have a right angle triangle. Now, I believe now you can follow. The first question says express QR. Express QR. Want to express QR. We're looking for side QR in terms of H and theta. First of all, we need to look where there's this QR. QR, it is in these two triangles. But where do we have H and theta? H is there, it is in this triangle, and theta is there, which means you have to use this triangle to express QR. The first, this triangle here. To do that, we're going to say in triangle SQR. So since this one is a right angle triangle, we can use SOHCAHTOA. So we are considering angle theta. So this is the opposite, the adjacent, and the hypotenuse. Let's check. The opposite is H is what we want. The adjacent is QR. So it means we must have H and QR. So we have to use tan here. So when I say tan theta, it's opposite of adjacent. What is the opposite there? The opposite is our SR, which is the H. What is the adjacent is the QR. We don't know. We want that QR over 1. Let's cross multiply. This will give us QR tan theta is equals to H. So let's divide both by tan theta to get the QR, tan theta over tan theta. So it means you have answered the first question. QR in terms of H. H is there. Theta is also there. Oh, in terms of a trigonometric function of theta. Sorry, guys, I did not read that. I apologize. In terms of H and a trigonometric function of theta. So we have done that. We have done that. So it's very important to understand that. Okay. Second question says express Q angle Q angle PR in terms of theta. Where's Q angle PR? Q angle is this one from P to Q and Q to R. We want this angle. So we've done that. It's 150 minus theta. It's 150 minus theta. We got it. Then the second one says, hence show that H equals to this. Obvious. It means now we're no longer using this triangle. We have to come up to, we have to move to the next triangle. QRP. Let's do this. Let's try using sine rule. If it fails, then we want to move on to cosine rule. In which triangle? In the second triangle. Because in the second triangle, okay, I want you to consider something. Here its angle is 30. Here it's theta. What is this angle, by the way? 150 minus theta. Okay, let's check something. This P, this is Q, this is R. So let's make this in small letter. So small letter P, small letter Q, small letter R. We know PQ, the size is 6 meters. So they told us that. Okay, it's 6 meters. That's 6 meters. QR, we have it, we just got it now. QR, we have it, we got it now. It's h over tan theta. So now let's try to use sine rule. So I'm going to say sine angle P over small letter p, sine angle R over small letter r, sine angle Q divided by small letter q. Let's check what you know. Do we have angle P? Angle P, we know it's 150 minus theta. We have small letter p, QR, we have it. We just got it now. QR is, we have it. Small letter r, it's the theta, we have it. Small letter PQ, we have it there. Small letter Q, angle Q, we have it, but small letter q do not. Why do you want to write everything in terms of ratio? It means now we'll have to use these two properties only. So I'm going to say sine angle P over small letter p, it's sine angle R over small letter r. Why doing this? If I happen to use the last one, we do not have PR, so it's one unknown and it's not what you're looking for. So what is angle P? Angle P, we know it's 150 minus theta. Small letter p is QR, we have it. Let me just write QR for now. Angle R is theta. Small letter r is PQ, which is 6. I believe you guys are following. Right, let's now simplify this. Let's cross multiply the expression. So it means we can use sine rule here. Let's cross multiply. When you cross multiply, this would be 6 sine 150 minus theta equals to QR sine theta. By the way, 150 minus theta is not a reduction formula. It means this is a compound equation, so we have to expand it using compound. So this will be sine 150 cos theta minus cos 150 sine theta. It's a compound angle equals to QR. We already know QR, so let me substitute. This will be h over tan theta multiplied by sine theta over 1. Let's now expand this. Remember, without using a calculator, it means you have to change this 150 to be 180 minus 30 as a reduction formula. Cos theta cos 180 minus 30 sine theta. Let's multiply the numerator. This becomes h sine theta over tan theta. I believe you guys are following. Okay? Then now it's 10 marks, so we need to work. 180 minus an angle, which quadrant, guys? 180 minus an angle is in the second quadrant, where sine is positive. So it means this expression here, this expression here, this one needs to be reduced. So it will be 6 into 180 minus this sine 30, it will be sine 30 cos theta. 180 minus an angle is in the second, where cos it's negative. I mean this one. So this will be negative cos theta multiplied by sine theta equals to h sine theta over tan theta. Okay, what is sine 30? Sine 30 is half. So it will be half cos theta here. Plus, because negative and negative is positive. Cos 30 will be positive root 3 over 2 sine theta. equals to h sine theta over tan theta. Let's remove the brackets on the left-hand side by multiplying by 6. If we multiply everything by 6, the first one will be 6 cos theta, will be 6 cos theta, 6, oh, I meant to say 3, sorry, I apologize. 3 cos theta, so this will give us 3 cos theta plus, this side will be root 3 sine theta. Okay, on the right-hand side, this will be h sine theta over tan theta. By the way, we need to remove the brackets. Yes, let's just cross multiply this over 1. We want h. Cross multiplication, this will give us h. Let me write it this side. It will be h sine theta equals to this side. If I put it inside, this will be 3 cos theta plus root 3 sine theta multiply by tan theta. So now, to do this, I think here we can just do this. Let's say we can do this in 2 ways because we want to end up with tan theta here. And to end up with tan theta, what we can do is we can just do this. Let's divide everything by sine here. Sine theta. And everything by sine theta. Look what will happen. Because this one is just a multiplication, it will affect these two expressions here. So it means this will be h equals to, this side it will be 3 cos theta divided by sine theta. I hope you're following. Plus root 3 multiplied by sine theta divided by sine theta. Outside we multiply by tan theta. Look what will happen. What is cos over sine? Remember, we know that sine over cos is tan. So how about cos over sine? It's 1 over tan. So it means this will be 3 times 1 over tan. Okay, let me just put it like this. So it will just be 3 over tan. 3 over tan theta. But these two will divide. So we're going to remain with root 3 into tan theta. Let's remove the brackets by multiplying everything by tan theta. 3 over 2 multiplied by tan theta. This will be 3 plus. I think I've missed something. Oh, okay. When we multiplied here by 6. When we multiply here by 6, supposed to say 3 root 3. 3 root 3, I apologize. 3 root 3 here. So it means even if this would be 3 root 3 tan theta. So what is the common factor? The common factor is 3. So we're going to pull 3 out. So we're going to be 3 into 1 plus root 3 tan theta. So we have proved. So I believe you guys are following. I believe you guys are following. If you don't understand, guys, kindly reach out to me. Okay, then the last question says, use the result in question 6.2.3 to calculate the value of theta if the height is 12 or 12 meter. So they want us to use this expression when we know that the height is 12. To do that, so we just substitute and say, okay, h equals to 3 into 1 plus 3 times theta. We want to know the theta when the height is 12. So it means we substitute here by 12, 3 into 1 plus 3 times theta. Let's divide everything by 3. Let's divide it by 3 and by 3. 12 divided by 3 is 4. So it's 4 equals to 1 plus the root of 3 times theta. Let's transpose 1 to the left-hand side. 4 minus 1 is 3 into root 3 times theta. So let's divide there by root 3 and divide there by root 3. Then we're going to have tan of theta. It's 1 over root. No. I apologize. Tan of theta, it's 3 over root 3, which is just the same as times 3 root 3. It's root 3 over 3 over root 3. Yes, just root 3. So it means it's the same as root 3. So let us make second function tan 3 to get the angle. 3 divided by second function tan of root 3. The angle will be 60 degrees. The angle will be 60 degrees. Isolate your diagram. Try to look for common sides, very important. Then you'll never go wrong. Remember, practice makes perfect. Okay? All right. Without wasting time, let's move on to the last one. Then the other two, you'll go through them. Remember, it's question 5 and question 4. Okay? All right. Let me just wrap up with the last one. Which is question 7. Right, let me try to zoom out. Okay, in point B, point B, C, E, and yeah, E lies in the same horizontal plane. A, B, C, D, it's a rectangular piece of board. A, B, C, D. We know rectangular, it means two opposite sides are parallel, are equal and also parallel. It's a rectangle. Then now we know that, okay, already we know that AB is the same as CD and AD is the same as BC. Okay? CD is a triangular piece of board having a right angle at C, okay? Each piece of board is applied perpendicular to the horizontal plane and joined along DC, okay? As shown in the diagram, the angle of elevation from E to D, it's X. So we're given this angle here, it's X. B angle EC, it's 2X. Okay, so what we're gonna do, let's isolate this. Obviously, we're not gonna talk about the rectangle, we'll see it later. Let's just isolate the triangle. The first one is that's 90, we're told it's C here. That's E, the angle here, it's X. And there's D. Oh, we also can get this angle here. What is the angle here? 90 minus X. And since this one is a right angle, we can use SOHCAHTOA. Okay. The second one, here the second triangle. We need to get all the information in the triangle. So there's B, there's C, and there's E. What is the angle here, guys? 2X. What is the angle there? 30. So it means you can get this if you want this. So I'm going to get it. The angle that you know plus 30 plus 2x is 180. Sum of angle net angle. 180 minus 30 minus 2x. So this would be 150 minus 2x. I believe you guys are following. Let's identify a common side here. Okay, let's check. DC, it's in this triangle, but it's not in here. CE, it's a common. CE, it's common. So it means this is the most important side that we have to use. Okay, then, okay, fine. What is the first question now? The first question says, show that DC, let me write it here. Show that DC is equals to BC over 4 cos squared x. Okay, first of all, let's check something here. Where's this DC? Okay, DC is in the first triangle. Let me call 1 and 2. DC is in the first triangle. It's here. And in DC, what do we want? We want this DC to have BC. BC, where's BC? BC is in this triangle here. So it means you have to link DC and BC. And how do you link DC and BC? By a common side. You have to use a common side. so it means now we're going to say in triangle DCE. Let's write the DC we're looking for in terms of CE and the trigonometric ratio of x. Why CE? It's a common side. So I'm going to say soccer tour, guys, it means to use this opposite. Let me say, sorry. Soccer tour, let's check. This will use the, sorry, man. It will use the opposite adjacent. So we'll use tan. So it will be tan x. It's opposite of adjacent. The opposite is DC, is what you're looking for. The adjacent is CE. Okay? We're going to write DC to have CE inside and X. Why CE? Because C is a common side. So let's make DC the subject. So DC equals to CE tan X. So which means if we can get CE, then we'll be able to get the answer. And guys, why is this CE? CE, it is in the second triangle. Let's go to the second triangle. And we want BC to be part of, okay, fine. So it means we're going to say, okay, in this triangle, this is small letter E, small letter B, small letter C. I want us to use sine rule. So in triangle BCE, what is the sine rule? Sine rule, we can say sine angle E divided by small letter E, sine angle B divided by small letter B, sine angle C over small letter C. Let's check the unknown. Remember, in our equation, we have to have CE. We must have the BC, because the BC is part of what we are looking for. Angle E, do we have angle E? Yes, we do have angle E. It's 2x. Small letter A is our BC. Is that BC? And the small letter is the BC that we want. So it means the BC must be part of. Angle B, do we have angle B? Angle B is 30. Small letter B is the CE we are looking for. So it's fine. So we can use this as our CE. So we're going to use these two. Let's now do the substitution. I believe you guys are following. Let's do the substitution. What is angle E? Angle E, we do have angle E. It's 2x, so this will be sine 2x. Small letter E is the BC. Remember, BC should be part of. Angle B is 30. Small letter b, we have small letter b, it's the CE. CE, remember we want to explain. Okay, guys, I apologize. I had network issues. Let's continue. Okay, as I was saying that this we had sine 2x. Let me just write here. Sine 2x over small letter, which was the BC, equals to sine 30 divided by CE. Remember our expression first, we got DC to be equals to CE times X. So this was the first equation. So let's now cross multiply. So the CE sine 2X is equals to BC sine theta. Remember, BC is part of. So let's divide there by sine 2X. And we divide there by sine 2X. Now we know CE. CE is BC sine theta. And sine theta, we know it's half over sine 2X. It's okay. Well, even if we do not expand, then let's come to this expression where there is CE, we substitute by that. So CE will be equals to BC sine of theta. We know sine of theta is half over sine 2X multiplied by tan X. Let's now work out this. BC sine theta. Okay, let me just say sine theta. I know this. Over what is sine 2X? Sine 2X is a double angle for sine. Same time multiplied by tan sine over cos. And we know that whenever we have multiplication, we can divide terms that are the same at the numerator and denominator. So those two have divided. So we're gonna remain with, by the way, okay, here we're gonna remain with BC. What is sine theta? It's half divided by here it's 1 and the numerator it's 2 cos x multiplied by cos x. This is 2 cos squared x. Now let's rearrange this. This is the same as the DC is the same as half BC. Then divide by 2 cos squared x over 1. Let's now change division to multiplication. It means this will be DC, not BC. DC equals to BC over 2, this one, times changing division to multiplication, 1 over 2 cos squared x. Let's now multiply the numerator. BC times 1 is BC. Denominator 2 multiplied by 2 cos squared, this gives us 4 cos squared x. Remember, I'm showing all the steps. That's why the expression is long. It's long. Then the second one says, okay, we have answered the first one. The second one says if x is 30, determine the area of ABCD. Now to calculate the area of ABCD, guys, it's a rectangle. Optimization of ABCD is just the length times breadth. One side multiplied by the other. Now, but they're saying we need to show that the area of ABCD is 3AB squared. So it means AB should be part of the expression. And how to do that? We come back to what we have done here and say DC is BC over 4 cos squared x. And we are told that x is 30. So from this, where there is x, let's substitute by 30. So DC will be BC over cos 4 cos squared 30. We have to simplify this. So we're going to have 4 into cos of 30 squared. So this will give us BC over 3. And what does this mean? It means now if we cross multiply this, we determine the size of BC. The BC is 3 times DC. BC is 3 times DC. So it means here is 3 times DC. But don't forget, we know that AB and DC are equal. AB and DC are equal. AB and DC. So it means where there is DC, you can put AB. So what does this mean? It means BC is also 3 times AB. And by the what is the area of a rectangle? One side times another. So we can say the length here is BC and the breadth is AB. Already, what is BC? BC is 3 times AB. So if you multiply by that, that will be 3 times AB squared. Remember, there are many ways to skin a cat. I show all the steps to accommodate everyone, but when you are practicing on your own, you can skip some of the steps. Remember, practice makes perfect, ladies and gentlemen. So this is the last one. I left 2 questions, which is question 4 and question 5. Kindly go through them, and wherever you don't understand, reach out to me, then I'll be glad to assist you. Practice makes perfect. Isolate the triangle, determine all the angles in the triangle. If you have a right angle triangle, just know that you will have to use SOHCAHTOA. But if you don't have, then you're not going to use SOHCAHTOA. You have to try sine rule and cosine rule. Okay, I believe you are following. Okay, this is the end of the session, guys. Kindly don't forget to like, subscribe, and share. That would be much appreciated. Thank you very much, ladies and gentlemen. Bye-bye.